Angles of triangles. Objective. I will use the triangle angle sum theorem to solve for missing angle measures of triangles.
All right, so we're going to be using the triangle angle sum theorem and another one to help us solve for the measures of missing angles in triangles. Yes. All right, so we have our first one, our triangle angle sum. There it is for you. Simply put, it says that if you have a triangle and you add up all the measures of the angles inside the triangle, you're going to end up with 180 degrees when you add up the measures of those angles inside the triangles. Right? That's what it says. You are going to have to write a proof for the triangle angle theorem, but it requires the use of something called an auxiliary line. That's one that you're going to draw in and add to the picture, not one that's already given to you. So I think I'd like to hold off on the triangle angle sum theorem proof for a little bit so that we have some time in class and I can walk you through drawing that auxiliary line and what it would look like. Okay. It's also going to require the use of the parallel postulate, which I hadn't given to you before. I'll explain what that is in a moment. Right now, here are the properties of congruence written out very formally for you. The property of congruence that allows you to say a thing is congruent to itself, which totally sounds like this should be common sense, but it has a proper name. So you have to call it by its proper name if you're trying to state that a thing is congruent to itself. Okay? Symmetric property just means you can write congruent statements in any order you want. And transitive we've already been using a couple times already. So let's talk about the parallel postulate. There it is. Let me zoom out just a little bit so that we can see it. There we are. Parallel postulate says that if you're given a line and some point that isn't on the line, like this one right here, it says that you can only have one line drawn through that point that's parallel to this first line. So you have something that looks like that, which totally makes sense, right? Because if I were to tilt this line, it's going to end up crashing over here, right? And if I tilt it the other way, it's going to crash over here. And so this is one of those things that when you read it and you draw it and you look at it, you go, oh yeah, totally makes sense. Duh. Of course, there's only one way to draw this. Later, I'm talking next semester, we're going to be discovering what happens if we change the answer to this question of how many lines. And we allow it to be something other than one. We'll explore that. We'll take a few days to explore that. But for now, the triangle angle sum theorem, the fact that triangles add up to 180 degrees, depends on the parallel postulate where there's one and only one parallel line to another line. Okay? Make sense? Just sort of. The idea that we could have more lines or less lines parallel is weird, I'm sure. All right, let's look at this one. This is the exterior angle theorem. The exterior angle is going to be the one out here. When you take one of the sides of your triangle and you extend it into a line, this angle that gets formed right here will be the exterior one. Okay, so there's your exterior line. It says that this measure is the same as if we added up the measures of the two remote interior angles. So the question is, what are remote interior angles? Well, first question I have for you is, what does the word remote mean? Where have you heard it before?
Paradise.
Paradise? Like a remote island? Okay, tell me what a remote island is.
Like,
In the middle of nowhere.
yeah, like it does like no civilization.
In the ocean.
In the middle of nowhere, far away from civilization. Okay, where else have you heard the word remote?
Like a TV remote.
My house.
Like a TV remote. Yeah, yeah, Mom goes, pass the remote. It's short for remote control, right? And it allows you to control the TV from where?
From where you're sitting.
From where?
Wherever. As long as you're in reach, that's easy.
Somewhere far away from the TV.
I can control the TV from my phone. I can control it from my phone.
That's a very impressive remote control. I heard someone say that I can control it from my phone. Yeah, you can turn your phone into a remote. That's such a fun game to play. against younger brothers
Yeah.
and cousins when they're not looking. You're just like, click, I'm texting. I don't know what you're talking about. I'm not controlling the TV from over here. But, right. But this concept of a remote control is a thing that gives you control at a distance, far away. And so remote is going to mean for us far away. Like a remote island is far away from civilization. A remote control gives you control from far away. So if I'm looking at this triangle with its exterior angles, it says remote, far away, interior, inside, which means the angles are this one and this one. Okay? So those are our remote interior angles, and if we add those up, we will get the sum of this outside exterior angle. Let's do some practice on these, shall we? We shall. All right, start with, please, first, the front side of your study guide where we're looking at triangle angle sum. The exercises on the bottom, 1 through 6. Pick a number, 1 through 6.
8.
I heard 3, and then I heard 5. 8, it does not belong between 1 and 6 in this universe. All right, so there's question exercise number 3 we'll do. We're looking for the measure of angle 1 and the measure of angle 2. What does this little marking right in 90 degree, which means this is also?
A 90-degree angle.
How do you know?
Because there are back to
Because
back.
that's what I was That's how we learn.
Okay, because that's how you were taught, but the question is, why? Ladies and gentlemen, why? But how do you know it's a right angle? How do you know the one that wasn't marked is 90 degrees?
Oh,
We're given the one that's marked. That little marking means
Because
90 degrees and we're okay. Huh?
But there's the 3
If you put in the
times
corner of a page because it's there, it'll like the perfect.
2. Because the numbers there, it says 30 times 2, and 3 times 2 is 60, so the same.
No, doesn't make any sense.
He was trying. He really was.
If you do the measurements on it, it'll go up to 90.
Because if you measure it, it'll become 90. Because if you put a corner of a piece of paper, which again is measuring, it'll be 90. But the thing is how do you know without having to go to measurement? Because your measurement could be wrong.
That's what the little square symbolize.
I agree that on this side, that's what the square symbolizes. The question is, ooh, I like it because we have maybe some sort of angle relationship, which is where you're grabbing the word corresponding from. Some sort of angle relationship. Ladies, up here. Thank you. The angle relationship that you're looking for is the relationship that's creating this straight line. We have 2 angles creating a straight line, which measures 180, he said. So I have 2 angles adding together equaling 180. One of them is 90, so what must the other one be? And that's why. Because these 2 are a linear pair and one of them is 90. In order for them to add up to 180, the other one has to be 90. Make sense? All right. So you're absolutely right. Let's look at the measure of angle 1. I know these 2 are 90 and 60. What must this third one be? How do you know?
Oh, wait. I think I'm wrong. No, it's 30.
It's 30. You're absolutely right. So the question is why?
Because the triangle equals 180.
Because a triangle adds up to 180, and we need 30 to fill the triangle. Let's write that formally in algebra. The measure of angle V plus, okay, we're going to put W, but we mean this one right here. V, which is this angle here.
Oh, okay.
W, which we mean this one right here. And then 1, we mean this one over here. I'm trying to write big for you guys to see, and I'm failing. It's ending up really small. All right. What's the measure of angle V? What's the measure of angle W? What's the measure of angle 1?
30.
We don't know yet. We're pretty sure it's 30, but we're going through and we're doing the algebra to prove that it is 30. We don't know yet, so leave it as the variable. Now what? Add 90 plus 60 is 150. I'm going to just believe you. Now what? Subtract what from what?
150 from 180.
Lovely. When I do that, I end up with? Bare minimum, this is the amount of algebra that needs to be shown.
It's simple.
Yeah, I'm getting now. You say simple, but I'm getting some papers because I'm grading right now. I'm getting some papers where there's no algebra work shown, period at all, nothing, not even setup. They're just answers. Ladies and gentlemen, I'm getting papers with just answers. I'm assuming, benefit of the doubt, you guys are brilliant and can look at it, do it all in your head, and just write answers. Which is amazing and blows my mind, but I don't know where you're getting them from. I'm not that smart. So I need you to walk through bare minimum this much process so that I can read your mind by reading your paper. Otherwise, I have no idea what you're doing and I can't give you credit for whatever wonderful thoughts you had in your head. Okay? So help me out, make sure that I can read your minds, write down what you were thinking. Do you see how you would get the measure of angle 2? It's the exact same sort of way, right? Very nice. Let's flip the page and go to the other side. This one is looking specifically at not only the triangle angle sum, but also the exterior angle theorem. So pick a number 1 through 6. Don't do 4 because 4 you can use triangle angle sum.
6.
I heard 6 nice and loud and clear, so let's look at number 6. There it is. All right. Do we have an exterior angle?
Yes.
Yes, right here. And we have 2 remote interior angles. Here and here. According to the exterior angle theorem, what do we know?
That they are congruent.
Reread the exterior angle theorem. The measure of the exterior angle equals the sum of the measures of the 2 remote interior angles. It's a G. Notice, gentlemen, notice that I had to write the name of the exterior angle with all 3 letters. Because if I just wrote angle G, like which angle G am I talking about? Exactly. It could have been the one I colored yellow or the one I colored white inside the triangle or the one I colored white outside the triangle. Like there's 3 angles there. And I don't know which one we're talking about. So I used the 3 letters to make it clear, the one I colored yellow. All right, let's substitute for what I know. Do I have the measure of the exterior angle?
Yes.
Yes. Do I have the measure for this remote interior? No. Yes and no. No, I don't have a number, but yes, I have a variable. So I'm going to replace it with the variable. Make sense?
Yeah.
All right. Do I have the measure of the other remote interior? Yes and no. Replace it with the variable. Now what?
Don't you add?
Yep, I would add and it becomes 2x. And now? Divide 52 divided by, 58 divided by 2 is
24.
29.
Nicole, what the heck?
Double check. Use the calculator app and confirm.
I believe it's 29.
29 says the calculators. No, I see where he's going because 2 times 4 is 8. The thing is on division, you have to divide the tens place first. So 5 divided by 2 is 2. You have 1 left over because 2 times 2 is 4. 4 plus 1 is 5. So that one goes with the 8. I have 18 now that I'm dividing by 2. 18 divided by 2 is 9. Make sense? Okay. And you found the value for x. Now you need the measure of angle F. What is the measure of angle F? 29. Any questions? All right, thank you very much.